In today's lab, we will be looking at the particulate theory of matter. The particulate theory of matter states that matter consists of very small particles in a continuous state of motion. The theory was put forward by English scientist John Dalton in 1808. He proposed that all matter is made of tiny indivisible particles called atoms. Dalton put forward 4 postulates. The first one was that all matter is made of atoms. The second one is that all atoms of a given element are identical in mass and properties. So for example, all the atoms of the element sodium are exactly identical. The third postulate was that compounds are combinations of 2 or more different atoms. And the fourth one was that a chemical reaction is just a breakdown and rearrangement of atoms. The particulate theory of matter formed the basis of all science, and even though Dalton wasn't able to prove his theory at the time, over time other scientists were able to do this. The 3 phenomena which prove the particulate theory of matter are diffusion, osmosis, and Brownian motion. Diffusion is the movement of particles from a region of high concentration to a region of low concentration. For example, when you spray on your favorite perfume, it moves from a region of high concentration on your clothes to a region of low concentration around the nose of people nearby. This simple phenomenon proves that matter is indeed made of particles which are in constant motion. Osmosis is a form of diffusion that is specific to the movement of water particles. In 1826, R.J.H. Dutrochet realized that water molecules move from a region of high concentration to a region of low concentration across a partially permeable membrane. Now, a partially permeable membrane is one that allows only specific substances to pass through it. Partially permeable membranes are found in the cells of most living things. Brownian motion was discovered by Robert Brown in 1827. It is a random haphazard movement of particles suspended in a fluid, such as the movement of pollen grains in water or the random movement of dust particles when sunlight shines through a window into a dark room. In today's experiment, we will be looking at diffusion. Specifically, we will be looking at how temperature affects the rate of diffusion. Looking at our setup, we have 3 500 ml conical flasks. The first conical flask contains hot water, the second one contains room temperature water, and the third one contains cold water. To each conical flask, we are going to add drops of food coloring and observe the time taken for the color to change. As you can see, the flask containing the hot water changed the quickest, while in the flask containing the cold water, diffusion is still taking place. Now, what did this prove? This proves that matter is indeed made of particles in constant motion. The addition and removal of heat from the water molecules consequently sped up and slowed down the movement of the particles. The greater the heat added, the greater the movement of water particles. This led to a lot more collisions taking place with the colored particles, causing the colored particles to diffuse quicker in the hot water than in the cold water. In the cold water, the motion of the water particles were reduced, leading to less collisions taking place with the colored particles. Therefore, the rate of diffusion was drastically slowed down. You can try this experiment at home using brown sugar and water. Observe the rate at which the sugar dissolves in the hot water compared to the cold water.